So I'm not fortunate enough to have a lab here at York. In fact, it would be pretty impossible since most of the lasers I use cost between 5 and 50 million pounds a piece. So I tend to spend my time applying for time at national facilities, national labs here in the UK and overseas. If we are awarded time in any of the laser facilities, then along with my PhD students we'll travel to the lab in the UK, maybe France, maybe Germany, and conduct the experiment there for between 3 and 8 weeks. And then we'll come back here and the rest of the time will be spent doing data analysis. One of the things I really like about science is it gives me the opportunity to travel. It allows me to meet people from all over the world, it allows me to collaborate at national labs in California, Japan, Germany, France and here in the UK. And that not only is it fun to be in California, but it's also fun to meet different people and experience and cultural differences and also differences in the way you work. So I was very fortunate that during my PhD, my postdoc was from Germany. And he came over and everything I learned from my PhD supervisor was a little bit different from everything I was learning from the postdoc. And that idea of sort of melting pot of ideas and travelling and gaining information from all around the world it's really rewarding. You can feel that it makes a difference to your own experience, your own abilities, and your own ability to pass on that information to the next generation of scientists. I guess the coolest lab I've ever visited is probably the Lawrence Livermore National Lab in California. It's got the world's largest and most expensive laser system. It's called the National Ignition Facility, or the NIF. It cost about between $6 and $8 billion to build. It consists of 192 laser beams, and it covers the area about the size of 3 football pitches. These 192 beams are all focused to about a square centimetre in a capsule inside a target chamber that's 10 metres in diameter. It's a huge and really impressive facility that does some amazing science. And not only that, but if you want to see what it looks like inside, you can watch the movie Star Trek Into Darkness, as it was used as the warp drive for the movie. So I've talked quite a bit about Wakefield Acceleration, and I remember there was one particular occasion when we were taking the data for the Nature article. We have a camera that looks down on the Wakefield from above. And because effectively when there's no gas, all you see is a circle, which is the top of the gas jet where the gas comes out. And this is about maybe a couple of millimetres in diameter. And we could only find one lens that would do the job, so outside the vacuum chamber we put a lens, and then to get an image in focus we needed to put a camera about 2 metres further up. So we built some construction that allowed the camera to sit at the right position above the gas jet and above the lens. And we started taking our data, and in the first shot you see in the centre of the screen a nice big circle where the gas jet is. And we took some more shots and a few more, and about 20 minutes later we noticed that the gas jet had moved slightly to the left. And we didn't think anything of it for that shot, so we took another shot and it looked as if it moved a little bit more to the left. And then it had moved a little bit more and a little bit more. And at that point I looked over to my colleague and I was like, that's strange, is someone moving the gas jet? And when we concluded that no one had moving the gas jet, there was only one rather disturbing conclusion to come to, as we all jumped and ran into the target area to watch the camera on its thing slowly tipping over and almost coming crashing to the floor. So needless to say, we managed to fix it, and I've never installed a camera without making sure it's firmly duct taped to the ceiling in the future.